L'Hopital's rule. Suppose there exists some positive reals such that f and g, and we know the first derivatives are continuous on an open interval a minus r and a plus r, then where n is greater or equal to 1, and we suppose also that f of a equals 0, f to the k of a equals 0 for k less than or equal to n minus 1, and g of a equals 0, g to the k of a equals 0 for k less than or equal to n minus 1, and g to the n of a does not equal 0, then f of x over g of x tends to f of n, f to the n of a over g to the n of a as x goes to a. Now proof. Since g to the n is continuous on a minus r and a plus r, and g to the n of a does not equal 0, it follows that there is some r greater than 0 with r less than or equal to this big R here, such that g to the n of t does not equal 0 for all t, such that a to the minus r is less than t, which is less than a to the plus r. Now let x be any real number such that our magnitude of x minus a is greater than 0 and r is greater than the magnitude. Then f, g and their first n derivatives are continuous on the closed interval with n points a and x. Now by Taylor's theorem we get this property here. Now by condition I, the first one here, where c lies between a and x, similarly g of x, and I don't want to say all that out, by condition 2 here, where d lies between a and x. Hence 0 is less than our magnitude a minus d, which is less than r, because of this condition, since g of n of t does not equal 0 for all t, such that a minus r is less than t, which is less than a plus r, we see g to the n of d does not equal 0. So g to the x does not equal 0, provided that this holds. Thus, if 0 is less than x minus a magnitude is less than r, then this holds. As x goes to a, we must have c goes to a and d goes to a, because c and d between a and x, c and d are between a and x. Moreover, f to the n of c tends to f to the n of a, as c goes to a, and g to the n of d goes to g to the n of a, as d goes to a, because f to the n and g to the n are continuous, and hence we get the condition here as x goes to a. Therefore, f of x over g of x goes to f to the n of a, g to the n of a, as x goes to a. That's L'Hopital's rule.